Good morning, students. This is next topic in chemical bonding chapter, that is covalent bond. Till now we discussed ionic bond, factors favorable for the formation of ionic bond, properties of ionic bond. Now we will discuss about covalent bond. What is the definition of ionic bond? The strong electrostatic force of attractions present between oppositely charged ions. That means in ionic bond, ions are present, nothing but cations and anions are present. Between them, some attractions forces exist. Here, those attractions forces are called strong electrostatic force of attractions. Because of that, one bond will form. That bond is called ionic bond. That is about ionic bond. Now, covalent bond. What is the definition here? If the bond is formed by sharing of electrons between two atoms is called covalent bond. I will discuss here. See, for example, take H2. That means this is molecule. In that molecule, two hydrogen atoms are present. Here, this is the example for covalent bond, because between two hydrogen atoms here covalent bond is present. Now, how that form between two hydrogen atoms? That is our topic here. See, what is the electronic configuration of hydrogen? 1s1. This is the electronic configuration of hydrogen. This is orbital representation of hydrogen. Similarly, same electronic configuration for another hydrogen atom also. So here you have to understand one point, that is, here this hydrogen contains only one unpaired electron. If orbital contains only one electron, that is called unpaired electron. So our point is what? Here two hydrogens contains two unpaired electrons. That means each hydrogen contains one unpaired electron. That unpaired electron present in s orbital having spherical shape. We know that already. This is hydrogen atom, s orbital of one hydrogen atom, plus this is s orbital of another hydrogen atom. It also having spherical shape. It contains one unpaired electron. It also contains one unpaired electron. What happens between these two orbitals? Some attraction forces exist because both contains unpaired electron. Automatically those two atoms comes close to each other to pair up. Automatically they get stability. So to get the stability purpose, these two orbitals comes close to each other. Then they both orbitals overlap like this. Because of attractions, those two s orbitals of hydrogen atom overlap like this. Then the two electrons paired here. This is called overlapping. This is called overlapping. Because of overlapping of two orbitals, any two orbitals, either s and s or p and p or s and p, because of overlapping of two orbitals, then one bond will be formed. Here that bond is called covalent bond. That means this is the representation for covalent bond. This hyphen represents covalent bond. Now this bond contains how many electrons? Two electrons. Wherever covalent bond is present, that bond contains two electrons. Before forming bond, this electron belongs to this atom, this electron belongs to this atom, before forming covalent bond. But after forming covalent bond, these two electrons belongs to either of the atom. That means these two electrons belongs to hydrogen atom as well as this hydrogen atom after forming the bond. That means this bond is formed by sharing of electrons. That is meaning of sharing of electrons. Like that, covalent bond will be formed between any two atoms, not only these two atoms. Next, here covalent bonds are two types. They are polar covalent bond and non-polar covalent bond. Polar covalent bond, non-polar covalent bond. Then now we will discuss about what is polar covalent bond, non-polar covalent bond. See, polar covalent bond means if the covalent bond is formed between two different atoms. If the covalent bond formed between two different atoms, then it is called polar covalent bond. For example, take CH4. In that CH4, its structure is like this: CH, H, H, H. So these bonds are called what? Covalent bonds. Here, these bonds formed between two different atoms, not same atoms. That is why this is called polar. Polar means what? Covalent bond should be formed between two different atoms. Then why it is called polar? Because, for example, take HCl. In that HCl also covalent bond is present. Here that bond is present between two different atoms. Then why it is called polar? Because see, compared to hydrogen, chlorine having more electronegativity. We know that point. Compared to hydrogen, chlorine having more electronegativity. Then what happens? These two electrons readily to move towards chlorine. What is the meaning of electronegativity? Tendency to share, to gain the shared pair of electrons by itself. That is called electronegativity. So because of more electronegativity of chlorine, these two electrons, the electrons which are present in that bond, readily moves towards chlorine. That means hydrogen is going to lose electrons, chlorine is going to gain electrons. Because of that purpose, we used to mention like this. This is called minus delta. Here plus delta. Why plus delta? Because hydrogen is going to lose the electrons, chlorine is going to gain the electrons. This delta is called partial. That means partial negative charge. This is partial positive charge. This indicates that what? Hydrogen is going to lose the electrons. This indicates that what? Chlorine is going to gain the electrons. Here these partial positive charge, delta, partial positive charge, partial negative charge, these are called dipoles. These are called dipoles. That is why it is called polar covalent bond. Polar means charges, poles. That is the meaning of that one. Next, non-polar covalent bond. Non-polar covalent bond definition is if the covalent bond is formed between two same atoms. There two different atoms. Here two same atoms is called non-polar covalent bond. For example, N2O2 H2S8. Because all are here same atoms. If that bond is formed between two same atoms, then there is no charge. There is no chance of exhibiting charge. See, for example, take H2, H. This is called what? Covalent bond. But in this case, here also two electrons are present between in that bond. But the problem is these two electrons cannot move towards two hydrogen atoms. Because this hydrogen having electronegativity 2.1. This hydrogen also having electronegativity 2.1. But both are having same electronegativity. That means both are having same strength, so that there is no chance to gain or lose the electrons between two atoms. Then there is no chance to exhibit either positive charge, partial positive charge or partial negative charge. That is why no polarity is there. That is why this is called non-polar covalent bond. So these are very simple definitions. Polar covalent bond means covalent bond formed between two different atoms. Then automatically there is a chance of exhibiting charges. That is why it is called polar. Non-polar covalent bond means it is formed between two same atoms. Then there is no chance of exhibition of charges because both are having same strength. These are the examples. Next, note. This is important. If E and this symbol is called difference. E and difference between two atoms is greater than, is more than 1.7. Then the bond formed between two atoms is more than 50% ionic. I repeat once again, listen carefully. If the En difference between two atoms is more than 1.7, then the bond formed between two atoms is more than 50% ionic. That means ionic means ionic bond. That means it contains positive charge and negative charge. That is the meaning of that point. I will show the example. For example, take NaCl. Chlorine electronegativity to 3.1. Sodium electronegativity is 0.93. This is chlorine electronegativity. These are experimental values. No need to remember these values. These are experimental values of electronegativity. Here, what is the difference? That means what is the difference between 3.1 and 0.93? 2.23. That means this 2.23 is more than 1.7. That means here En difference is more than 1.7. Then what is the point here? Then between these two atoms, more than 50% bond is ionic. That means ionic bond is dominating here compared to covalent bond. Here one more point is also there, that is between Na and Cl covalent bond is also there, but it is very less, but ionic bond formation is more. That is why ionic bond dominates covalent bond in this case. That is why we usually write Na plus and Cl minus. We usually we don't used to write like this, Na bond Cl, because here ionic bond dominates covalent bond. But what is the point? Between these two atoms, covalent bond is also there, but the chances are very less. Its percentage is very less. Ionic bond formation is more. That is the meaning of that point. Next point. If En difference between two atoms is less than 1.7, then the bond formed between two atoms is more than 50% covalent bond. In the previous case, if En difference between two atoms is more than 1.7, then between those two atoms more than 50% is ionic. But here, if the En difference between two atoms is less than 1.7, then between the two atoms more than 50% is covalent, not ionic. See, for example, take HCl. HCl, we know that electronegativity of hydrogen is 2.1. Chlorine electronegativity 3.1. Just now I discussed here. Between 3.1 and 2.1, what is the difference? 1. That means its value is less than 1.7. Its difference is less than 1.7. That means between hydrogen and chlorine, mostly which bond is present? Covalent bond is present. Mostly covalent bond is present. That is the meaning of that point. And one more point is there, that is what? Between hydrogen and Cl, ionic bond is also present, but its chance is very less compared to covalent bond. That is why we usually write hydrogen chloride like this, H bond Cl, not H plus Cl minus. So here you have to remember one point. Between two atoms, covalent bond is present as well as ionic bond is also present between two different atoms. Between two different atoms, ionic bond is present as well as covalent bond is also present. But the point is what? If its En difference is more than 1.7, then ionic bond dominates covalent bond. If En difference is less than 1.7, then covalent bond dominates ionic bond. Next, one more point. Between two atoms, 100% covalent bond is there. There is chance of 100% covalent bond, but there is no chance of 100% ionic bond. This is very, very important point. Between two atoms, there is a chance of 100% covalent bond, but there is no chance of 100% ionic bond. For example, Cl2. Between two chlorine atoms, covalent bond is present. Now this covalent bond is called what? We know that this is non-polar covalent bond because this is formed between two same atoms. We know that because just now we discussed it. But here the point is what? Between these two atoms, between these two atoms, this covalent bond is 100% covalent bond. There is no ionic bond because both are having same strength. Both are having same strength. Here no ionic bond is present. So what is the point here? Between two atoms there is a chance of 100% covalent bond, but there is no chance of 100% ionic. That 100% covalent bond is always formed between two same atoms. So this is all about covalent bond and types of covalent bond. Now next topic is properties of covalent compounds. Properties. These compounds are present in solid state, liquid state and gaseous state. Ionic compounds are present in only solid state because of strong electrostatic force of attraction. But these are present in solid state, liquid state, gaseous state. Next point. Ionic compounds have high melting point, boiling point, but they have low melting point and boiling point because of covalent forces. Next, exception. Graphite and diamonds, silicon have more melting point due to giant polymeric structure. Graphite, it contains only carbon atoms. Between carbon atoms covalent bonds are present. Diamond, here also carbon atoms are present. Between carbon atoms covalent bonds are also present in this case. I discussed already these points in class 10 carbon atoms compounds chapter. So what is the point here? These are covalent compounds. Being a covalent compounds, they can exhibit more melting point, boiling point because they have giant polymeric structure. That means they have large structure. Next, covalent compounds readily soluble in benzene CCl4. That means these are soluble in these compounds because these are also covalent compounds. That means covalent compounds soluble in covalent compounds. That is the meaning of that point. Exception. This is exception. Glucose, sucrose, these are covalent compounds, but they are readily soluble in water because they form intermolecular hydrogen bond. I will discuss later what is hydrogen bond. Glucose, sucrose, these are covalent compounds, but these are readily soluble in water because of hydrogen bond. Water is a polar compound, but glucose, sucrose, these are non-polar compound. Being a non-polar compounds, here they are readily soluble in water due to intermolecular hydrogen bond. Next, all covalent compounds do not exhibit conductivity except graphite. I told you in all ionic compounds do not exhibit conductivity in solid state, but they exhibit conductivity in molten and liquid state or aqueous state. But all covalent compounds do not exhibit conductivity, but graphite exhibit conductivity. That is why we use graphite rods in cells, graphite electrodes. Next, covalent compounds exhibit isomerism, but ionic compounds does not. I will discuss this point later. Just remember that point. Next, the reaction between covalent compounds is very slow because in covalent compounds bond formation and bond breaking and bond formation takes place, while in the reaction between ionic compounds it is very fast because of exchanging of ions. In covalent compounds bond breaking and bond formation takes place in reactions, but in ionic compounds only exchange of ions takes place. It is somehow fast compared to bond formation and breaking. So point is what? Reactions between covalent compounds is very less, but reaction between ionic compounds is very fast. These are all about properties of a covalent bond. This is all about covalent bond. Thank you.